Question 1. Convert the decimal number 25 to binary. So we know with binary we're going to have 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4. We won't need 2 to the 5 because 2 to the 5 is 32. So in looking at this, probably we'll need 16 plus 8, these two over here. That's going to give us 24, and then we would need 2 to the 0, which is 1. So we're going to get a 1, 1, 0, 0, 1 would be your number. 1, 1, 0, 0, 1 would be your binary number for that. Outline 2 advantages of storing a text in digital form rather than an analog form. Now, I just want to point us to the PowerPoint that we have for this unit here. So these are the different advantages and so forth between digital and analog. Now notice here that we're talking about storing a text in digital form rather than in analog form. So in digital form, what happens is that every single letter, every single punctuation point and so forth is given a specific binary number, binary code. And this can be reproduced very, very quickly. So we get it can be reproduced really well because every single letter can be given a binary code, and therefore it's not going to be subject to wear and tear or damage over a period of time. So the storage of it is really good also, because you can store huge amounts of information using a binary code. You can for instance have on a CD or on a memory stick or so forth volumes and volumes, where if you had it in if we had it in the analog form, in terms of books and so forth, would be much more difficult. And if you wanted to retrieve, if you wanted to find that information, it's also much quicker. Just think of using the internet for finding information to going to a library, a public library with books. It just takes much longer. So the speed at one could use to retrieve it is much, much faster. So these would be your, here you just need to list 2 of them. So you need to make sure that you know all those, the advantages and disadvantages. The one advantage of your analog, which is that it's indistinguishable from the input. So it really, there is no, you're looking at the original thing and that is being stored, where with digital you're always changing it into binary code. So you do get that the original quality may be higher than the binary code, but over a period of time it can lead to corruption. Things can break down, fall apart, and so forth. Question C, it says define the term magnification as it applies to a CCD. Okay, so when we go to our definitions, magnification is the ratio of the length of the image on the CCD to the length of the object. So it's the length of the image on the CCD to the length of the object. That is your magnification. And I seem to have missed out question B, which says state with reference to their structure why more data can be stored on a DVD than a CD. Now a DVD uses light of a shorter wavelength, so it uses a wavelength on a DVD which is smaller than the wavelength for a CD, and therefore the pits, because your depth of your pit is a quarter of the wavelength, the depth of those pits can be less. And because they're less, you can actually have multiple storage. You can actually have layers of this within the DVD. Now again, just going back to the PowerPoint, And just bringing up another diagram here. Here we are. So with the DVD and the CD, basically what happens is that you can have your pits and your bumps can be smaller and they can be much closer together. So because the wavelength is less, this distance over here can be less, this over here can be less, and this depth over here can be less. So you can fit in many more bumps and pits because of that shorter wavelength. And also what happens is that the distance between your pits and your bumps and so forth, this distance between the two is less. So you can have them closer together. And also with the DVD, because these are less, you can have multiple layers. So you have multiple layers with your DVD. So multiple layers. Going back to this question now, so we've answered B. Going to D. It says a digital camera is used to photograph a particular object. Two small marks on the object are separated by a distance 2 times 10 to the negative 3. So we get 2 times 10 to the negative 3 meters. That's actually your object distance. And then it says the camera has a magnification of 1.4 times 10 to the negative 2. And the image collection area is 4 times 10 to the negative 4 meters squared. So that's where all the images collected. Determine the minimum number of pixels that the CCD on a digital camera must have in order that the image and the two marks on the object are just resolved. Now, when we say that they are just resolved, if they are just resolved, they need to be 2 pixels apart. In other words, if you've got your pixels are like each pixel, I'll draw it in slightly different. So that's 1 pixel. I'm just using green and red just to. So if you've got that either one falls on there and there, this is the distance here of the length 2 pixels. Then that will be resolved. So that's the minimum distance where you will get it resolving. So from this we can actually work out what our image distance is going to be, because our magnification is equal to our image over our object. So the image is going to equal 1.4 times 10 to the negative 2 times 2 times 10 to the negative 3. So we're going to get 2.8 times 10 to the negative 5. That's going to be our image distance. Now that has to be at least equal to or that needs to be at least equal to 2 pixels. That's the minimum that it can be. Therefore 1 pixel, the length of 1 pixel would equal half of this. So that will equal 2.8 times 10 to the negative 5 divided by 2, which is 1.4 times 10 to the negative 5. That will be the minimum length that we would require in meters. Now, the total area that we have, our area that we have here is given that it is 4 times 10 to the negative 4 meters squared. So the area of 1 pixel, the area of a pixel in this case would equal this 1.4 times 10 to the negative 5 squared. So that's the area of 1 pixel. So therefore the number of pixels would equal the total area, which is 4 times 10 to the negative 4, divided by 1.4 times 10 to the negative 5 squared. And when we do that, we get to around about 2 times 10 to the 6, and that would be the number of pixels that we would have. So this would be 2 megapixels. We'd need 2 megapixels for this to form.